second.
Yeah.
The speed of ultraviolet waves is 3 times 10 to the power of 8 meters per second. Calculate the frequency of the ultraviolet wave. Use your answer to question 5.2.
Okay.
So the wavelength is 300 nanometers.
Yeah. Wavelength is this 3 times 10 raised to power negative 7 meters.
And then they give you the wave speed
Yes, speed is given.
equals 3 times 10 to the power of 8. So they want frequency. So one sec. Frequency equals to wave speed equals frequency.
Yes. Times.
Frequency times wavelength.
Yes. Use this equation.
And then you want to find frequency. So frequency equals wave speed divided by wavelength.
Yes.
So 3 times 10 to the power of 8 divided by 300.
Not 300. You will, because this is in meters. So use meters 1. 3 times 10 raised to power negative 7. This is in meters. 300 is in nanometers. Convert it into
Okay.
meters.
3 times 10 to the power of 8 divided by 3 times 10 to the power of 7 equals
Negative
10.
7. Yeah, equals 10 hertz. That's correct.
Table 1 gives the wavelength of an ultraviolet waves and 3 other electromagnetic waves. Draw one line for each wave to the name of the wave. Wave G is X-ray.
No, wave G is not X-ray.
Is the wavelength bigger for the smaller the radiation?
Sorry. Wavelength, as wavelength increases, frequency decreases. So you can remember this R, M, I, R, V, U, V, X, gamma. So as you go towards gamma, frequency increases, and frequency and wavelength are oppositely related. They are inversely proportional. So as you go like this, low frequency.
So wave E is X-ray and wave
Yeah.
F is visible light.
Yes.
And the other one is infrared. Electromagnetic waves are transverse. Some other types of waves are longitudinal. Describe the difference between transverse and longitudinal waves. Transverse waves. Waves only go in one direction.
In transverse waves, the wave propagation is at 90 degree of the direction, and the direction of the wave and the disturbance, they make 90-degree angle, but longitudinal means they go parallelly. That is the main difference. So in transverse, oscillations are perpendicular to direction of energy transfer.
Teacher demonstrated some pieces of waves using a ripple tank. The teacher measured the time taken for 10 wave fronts to pass the mark Teacher repeated this measurement 3 times and calculated the mean. What's the advantage of repeating measurements and calculating a mean? Increases accuracy of results.
Yes, it reduce random errors. You can write this also.
Teacher measurements for the time taken for 10 wavefronts to pass a mark were 8.4 seconds, 7.8 seconds, 8.1 seconds. Calculate mean frequency of the wave. So there's 10 wavefronts. So you do 8.4 plus 7.8 plus 8.1.
Hmm.
8.4 plus 8.1 plus 7.8 equal, and then you divide that by 3
Yeah.
equals 8.1 is the mean.
Yes.
The 8.1 equals time
8.1 is for 10
equal waves.
waves.
So you do 8.1 divided by 10 to get the speed.
Yes.
8.1 divided by 10
So which will give you
equals
0.
0.81, 0.81, which equals wave speed. And then you want to find frequency, so frequency is equal to wave speed divided by wavelength.
No,
So
this
wave
is the
speed zero.
time, right? This is the time.
Is
0.8.
that no wait? That should be wave speed.
So because it says time taken for 10 wavefronts, right? These are the time taken for 10 waves. So when we divide it by 10, what we are getting is time. And we know the relation between time and frequency. 1 over t gives us frequency. So if I divide 1 over
So frequency equals what?
1 over time.
That's not in the table. Oh, there is.
That's not,
Frequency equals 1 over period.
yeah, period. That's what I mean. Time period. That's the same thing.
Okay.
Time period.
So 1 divided by 0.81
Hmm.
equals 1.23.
1.23. Yeah, that's correct.
In a different investigation, teacher wanted to determine the speed of water waves in the ripple tank. Teacher did not measure the wavelength of the wave. Explain how the teacher could determine the speed of the wave.
Hmm.
Teacher did not measure wavelength. No, teacher did. Count waves passing
Hmm.
in 10 seconds, then divide amount of waves that pass by 10 seconds to get the speed for each wave.
Use this formula, distance over time.
Then measure the ripple tank Find distance. What name is given to force A? No, kinetic energy. It was going forward.
Friction, right? It is a contact force between tires and the surface.
Figure 12 shows the velocity of the cyclist changing in a short journey. Determine the distance traveled by the cyclist between Y and Z. So from Y and Z. So
Y and Z, you have to
from
calculate
Y,
distance.
Y.
Let me take a different color. So I
Y is
think
30 seconds, Z is 70 seconds, so 70 minus 30.
Z is 70 seconds. Okay. So
70 minus 30 equals 40 seconds.
yeah.
Well, can I do it my way?
Okay. Actually, the what we have to find whenever the graph of velocity and time is given, and you have to find distance, what you can do, you can find the area of this thing between y and z. If you see between y and z, we have a rectangle and a triangle, right? So we need to find area of this rectangle and area of this triangle and add them. So if you see this, how much is this? 50 minus 30, this length is 20, and this is 5, 5.1 to, no, not 5.1, this is 5.4, right?
Yeah.
This height, I mean this height is 5.4, this is 20. So what will be the area of rectangle? Area of this rectangle will be
5.4 times 20 equals 108.
times it. So 5 point times 20, yeah. And okay, for this triangle, the base is 70 minus 50, which is 20. I mean this is the height, and if we see this is again same thing, 5.4. So 20 times 5.4 divided by 2, right? Base times height divided by 2.
20
This,
times 5.4 equals 108. And divide that by 2 equals 54.
yeah, 54. So 105 plus 54, this will give us total area, and that will be our distance.
It's 108 plus 54
Yeah,
equals 162.
162.
62.
Yeah, meters. That's correct.
Describe the force on the pedal causes the momentum about the rear axle. Force on the pedal. Force on pedal causes axle to spin and gear A turns anti-clockwise.
Yeah, which create a force on the
So
chain.
chain moves
Hmm.
with it,
Yeah,
and rear axle gear B moves too. Speed of the cyclist and trailer increased uniformly from 0 meters per second to 2.4 meters per second. Cyclist traveled 0.018 kilometers while accelerating. Calculate initial acceleration of the cyclist. Find final velocity, initial velocity equals 2 times acceleration times distance.
Yes, exactly. Final square
So
minus initial square is equals to 2 times.
final velocity squared minus initial squared equals 2 times accel times distance. So 2 times acceleration is 2.4 acceleration, then times the distance, we do 0.018 kilometers equals
Divided,
1.8,
yeah, 1.8.
0.018, isn't it, times
I mean,
1,000.
sorry, times, yeah, I mean, times 1000. So 1, 2,
It equals
3.
18 miles. So 2 times 2.4 times 18,
It is
2
18,
times
yeah. Okay.
equals 86.4. 8. So final velocity minus initial velocity is equal to 86.4.
Yeah, 24 square, 2.4 square,
So
2.4.
final velocity is 2.4 squared
Yeah,
minus 0 squared, which is initial,
yes.
equals 86.4. So 22.4 squared equals 2.4 squared equals 5.76
Yeah,
minus and then 0 squared. 0 equals to 86.4. So is it 5.76 meters per second squared acceleration?
5.7. No, you have to divide it by 36. 5.76 is just
Well, where
2.4
did
square.
36 come from?
2 times
There
18.
is, isn't it 2 times 2.4 times 18? That should be the calculation because it says acceleration.
But we have
And
to find acceleration. So if I keep acceleration this side and move this distance over here.
isn't that's initial acceleration, not regular. Isn't initial acceleration the initial?
Yeah, that is the initial acceleration.
So acceleration, acceleration,
Hmm.
uh, acceleration equals v squared minus u squared divided by 2 times s.
Yeah, 2 times distance.
So you do final velocity is 2.4
Yes,
squared
2.4
minus
square.
0 squared
Yes,
divided by 2 times the distance is 18 miles. So
18 meters. Yeah.
2.4 squared minus 0 squared divided by 2 times 18 is equal to 0.16.
Yes, that's correct. 0.16 meters per second square.
The resultant force of the tow bar on the trailer has a horizontal component and a vertical component. Horizontal force equals 200 newtons, vertical force equals 75 newtons. Determine the magnitude and direction of the resultant force of the tow bar on the trailer by drawing a vector diagram.
Okay. So horizontal force is 200 Newton and vertical is 75 Newtons. Determine the resultant. 75 is vertical, and to determine the resultant force, what we can do, resultant means these two, the points where horizontal vector and vertical, these two we need to connect. Okay, so we can find it using Pythagorean theorem. Okay, we can just use Pythagorean theorem to
So
calculate this.
resultant force is the hypotenuse.
Yeah, this diagonal.
Resultant force. Use what?
Pythagorean theorem. So 75 square plus 200 square is equals to hypotenuse square. Let's
So
say,
a squared plus b squared is equal to c squared.
yeah,
So 75 squared plus 200 squared equals
r square, which we need to find.
equals 445,625, which equals the resultant force squared. So then you do this, and then you root it. 45,625 is equal to 213.6.
213.6. Yeah, that is the correct answer. So this is the magnitude of resultant force and direction is this. It will go diagonally like this.
Mm-hmm.
And I think you need to use protector for direction also, for angle also. Okay, you need to use protector and you can tell how much is this angle if they ask about an angle. Okay,
Yeah.
next.
It made a moving coil loudspeaker. What is the name of the effect?
It is called motor.
What's the name of the effect moving coil?
This effect is called motor.
Explain how a moving coil loudspeaker produces a sound wave. The moving coil
Hmm.
produces sound waves due to diaphragm.
I think you should start with current because current
uh,
creates its own magnetic field, and then magnetic field create the magnetic field which is created,
Current creating a mag field
and the magnetic field created interact with the magnetic field with from the permanent magnet,
with mag field from permanent magnet
and then there is a force experienced by the core,
and a force experienced by the iron core
when the current is reversed the force is in the opposite direction.
when current reversed force in opposite direction.
Yeah, that should include in your main answer. current, magnetic field in all of these moving coil. Okay.
Student investigated how the loudness of sound from a loudspeaker depends on the number of turns of the coil, the frequency of the supply, and the number of turns of the work and the results cannot be used to make a valid conclusion. There's other external factors
Yeah,
and
because two variables are changed at
and
the same time, right?
factors and both variables changed
At the
at the
same
same
time.
time.
So it is impossible to state the effect of each variable.
Yeah.
Hmm. Next.
Mm, 1 second.
Okay.
Mm, 21, right? Um, I don't have the rest of it for
Sorry.
some reason. I don't have the rest of it.
Oh, you don't have it?
No.
Okay. So now let's do 2022. Okay.